I would like to go to Mars. The reason for SpaceX is not, if I go to Mars, that's nice to have, but what is important is that we establish a self-sustaining city on Mars. This is important for the long-term future of humanity or consciousness as we know it. So it's less about a few people to Mars, but more about creating a self-sustaining city on Mars and humanity becoming a spacefaring civilization, which I think is incredibly inspiring for the future. Mm. I very much think that, and I've said this many times, the making of a prototype is easy, but production is hard, especially if you have advanced production techniques that people have not used before. The vast majority of our engineering effort is in manufacturing, basically designing the machine that makes the machine. So I can't emphasize this enough. The factory, especially an advanced factory, is the hard part. The vehicle design is comparatively easy. So we will aim for 500,000 vehicles a year. That is our goal, to get there as quickly as possible. The only limitation on growth is how quickly can we make cars that are high quality, high reliability. That's the only governing element on the rate of progress. But nonetheless, even with extreme effort, I think it probably takes us until, this is just a guess, until roughly the end of 22 to reach that level of production. And this is the early days, and like, what is the internet fundamentally? It's not like a place you get email or post pictures or something. Really, the internet is like a nervous system for humanity. Whereas previously, communication was more like osmosis. In order for information to travel, somebody would have to call someone with a phone or write them a letter. And then that letter would be carried by another person to, by a series of people to the destination. Now, communication can happen instantly from any place in the world to anyone else and does not need a human to carry it. This is sort of like, at a cellular level, you see, say, a primitive multicellular creature will just communicate by osmosis from one cell to the next, or diffusion, essentially. So, but once you have a more sophisticated organism, you have a nervous system. The speed at which information can travel is much faster, and the accessibility of information is fundamentally different. If you want, now with the internet, you could be in the middle of the Amazon jungle with the internet, with a satellite connection, and you have access to all the world's information. Whereas previously, even if you lived in the Library of Congress in the US, where the most books are, you still would only have access to a fraction of the world's information. This is basically humanity becoming a superorganism to the degree that's not possible unless you have sort of essentially instant light speed communication from anywhere to anywhere, as opposed to osmosis, diffusion.
Thus, humanity transforming into something like a bioorganism, or at least behaving to the same rules.
Like the speed of information flow, and just, in fact, even not just speed, but qualitatively, the access to information was so limited before. I mean, now technically, you could teach yourself anything. Previously, say, universities had somewhat of a monopoly on higher education, but now MIT has all of their lectures online. You can buy all of the textbooks. You can do the tests online. You can learn anything you want. Almost, I'm not sure what you couldn't learn online, but you can learn right now online for free more than someone who did a doctorate could do before. I mean, what is the purpose of universities at this point? I think it's mostly just to hang out with peers.
Okay.
And have some fun and talk to friends.
And hanging out with peers.
This is not for information.
Good point.
I feel quite comfortable in predicting that the vast majority of Earth's electricity generation will be solar and wind, I should say. So wind has actually been, I've been surprised just how good wind has gotten. Wind power is extremely low cost. In fact, a lot of the best wind turbines are made in Germany. So the numbers are extremely good. That needs to be paired with large battery packs in order to buffer the wind power, because the wind speed changes and sometimes it doesn't blow wind. So but people want steady electricity. They don't want to just have electricity when the wind's blowing. So you have to pair wind turbines with large battery packs, and the same is with solar. You've got to buffer the solar power because obviously it's no sun at night, and sometimes it's very cloudy.
Do you see the growing electronic car fleet as a buffer for that, to be connected to the network, or is that unrealistic?
I mean, I certainly could be wrong about this point. The early roadsters we made had vehicle-to-grid capability, but nobody used it. So it cost some money. Nobody was using it, so we turned it off. We can easily turn it on right now, and actually easy, especially in Europe because of the way the connectors work. A little more. We need like maybe $100 accessory to be able to do this in the US. But I really think people want to have a home-based battery. Like I think the future that I see most likely is solar on the roof. So either where the roof itself, this roof tiles itself, are solar generating, or it's solar panels retrofit on an existing roof, combined with a local battery. We have a product called the Powerwall. It's very popular. And then you need to combine that with grid level solar and wind. And then have a long distance high voltage DC connections. High voltage DC is extremely efficient at transferring electric power. No need for superconductors, in my view. Like the energy penalty for long-distance electricity transmission is I squared R, so it's the current squared times resistance. So if you just increase the voltage, you can have the current be low, and then your I squared R heating is low. So you have high voltage, low current. You can transfer a tremendous amount of electricity with almost very tiny losses. So now you still need to pair that. I think there's other sources like hydro, geothermal. I'm actually not against nuclear. I know that some people don't like nuclear, but I think actually nuclear in a situation where there's not natural disasters is actually fine. I don't think you want to have nuclear in a place that has lots of earthquakes or tsunamis or something like that, or big hurricanes with a name. But in places where natural disasters are not a concern, I think nuclear is very safe. Well, I think most people are going to charge their cars at home. Generally, people will charge their cars where they charge their cell phones, and that's at home at night. This actually works fairly well with the grid usage because the electricity usage on the grid is mostly during the day. So you don't actually need a lot of new power plants, given that people primarily charge their car at night at their house. Now, not everyone can do that. Some people park on the street or something, and that's where you need supercharger stations or charging at work. When all transport goes electric, all road transport going electric, will approximately double electricity usage, total electricity usage. Like I said, because most of it's at night, that doesn't mean a doubling of the power plants. But we will need to increase the amount of solar and wind, geothermal, hydro, nuclear. I think this is fine, like I said, in order to solve the needs of electric vehicles. My guess is that the majority of the electricity production long term will be photovoltaics, solar, and paired with batteries, obviously. That's my guess.
I have 4 young children, so I have to advise them now a little bit differently.
I think people should have more kids.
Yeah.
Seriously.
Yeah. No,
totally. No, I mean, people don't have humans. Where are the humans coming from?
Yeah.
Yes.
No, you're right.
Got to make them somehow.
Yeah, you're right.
It take a long time to boot up.
Yeah, I have. What is you say this is a disruption you have in mind? Be interesting.
I mean, first of all, my goal is not disruption for the sake of disruption.
Yeah? Okay.
I really think there's some important things we have to solve in order for the future to be good.
Yeah.
I would say like my sort of algorithm or optimization is like, okay, what set of things do we need to do to ensure that increase the probability that the future is going to be good?
Yeah.
And so if we have to solve sustainable energy, this is tautological. If we do not solve sustainable energy, then we have unsustainable energy. Then it's just a matter of time before civilization collapses. We must But even if there was not an environmental issue, since the availability of oil is limited, this is not something we can sustain long term.
Yeah.
My original interest in electric vehicles was actually not environmental. It was out of concern, just studying physics, and I'm like, wait a second, we need to transition to solar electric, or we're going to have a problem, and we run out of oil, civilization collapses. That's a problem. Now, of course, the environmental concerns have added to the urgency, because the more CO2 we put in the oceans and atmosphere, the more we increase the probability that something will go wrong. Like I said, things are much more probability as opposed to certainty. But I think it's an unwise experiment to dramatically increase the CO2 in the atmosphere and oceans. Given that we know we need to transition anyway because we'll run out of oil. So why run that experiment? It's not. It doesn't make any sense. Okay. We know we have to transition to a sustainable energy economy. Then let's just get on with it. Let's just get on with it and not run the crazy experiment and see if what happens if the atmosphere has 2,000 ppm. CO2. This is crazy.
Okay.
Well, actually, I'm just curious, how many aircraft do you have?
Many.
A lot. Okay. So aircraft will certainly go electric. The energy density requirement to have aircraft with reasonable range is much greater than for cars or ships. So my back-of-the-envelope calculations suggest that you need about 400 watt-hours per kilogram to have aircraft with a decent range. This is with a range where it's comfortably over 1,000 kilometers, including some reserves and emergency power and that kind of thing. And then as you go above 400 watt-hours per kilogram, it gets really better in a nonlinear way because you spend so much of your energy getting to altitude. Once you get to altitude, the air is thin and your cruise power is quite low. So once you get, if you go to like 450 watt-hours per kilogram, even though it's, let's say 460 or 480 watt-hours per kilogram, you will double the range. So even like a 20% increase, let's say, in energy density will double the range to at least 2,000 kilometers, if not more. So, and we're getting there progressively with improvements in the energy density almost every year. So this is just watt-hours per kilogram. And a lot of the improvements in energy density actually also improve the cost because you need less material because you're able to put more energy in the same amount of material, which means less material per unit of energy. Where we are right now is a little over 300 watt-hours per kilogram, and some of the very expensive cells can do over 400 watt-hours per kilogram. But the high volume cells, I think, will start to approach 400 watt-hours a kilogram as well. So I would expect to see a significant transition to electric aircraft, starting initially with propeller planes because they're generally more efficient per kilometer than jets, and then turboprops, and then commercial airliners and that kind of thing. That transition probably happens, I think, reasonably soon. Within the next 5 years, we should start to see electric jets.